Okay, let's do an example of Descartes' rule of signs. So suppose we have something like this. Okay, what does Descartes' rule of signs tell us? Well, what we do is we count the sign changes of the coefficients. Now here, if I were to list the coefficients, they'd be 1, -1, -1. So that means the sign changes once when it goes between 1 and -1. So this tells us that there is exactly one positive root. Okay. Now, in fact, exactly what Descartes' rule of signs says is it says in order to get the number of positive roots, it has to either be equal to the sign changes, number of sign changes, or it has to differ by that by a lesser amount that has to be even. So if there's one positive root, the next possibility would be -1 positive root, which is impossible. We'll look at some more examples to get a better idea of that in a second. But if I call this f of x, I also need to take f of -x to get an idea of what's going on with the negative roots. Of course, there are other things. For example, if you know it has one positive root, you could use the fact that complex roots come in pairs. But let's assume that we don't know that at this time. So I'm just going to take f of -x, which is this. This has one sign change, right, because the coefficients are 1, 1, -1. So I get 1 negative root. So Descartes' rule of signs says that we have exactly one positive and one negative root. Now let's look at another example. Let's look at x cubed minus x squared minus x. Similar situation. If I count the sign changes here, I'm going to get one sign change. So this tells me there's one positive root. And if I take negative x and I plug that into this polynomial, I get minus x cubed minus x squared plus x. So this tells us there is one sign change, so that's one negative root. Okay, well, how can that be? Well, I can also pull out an x, and I see that 0, which is neither not considered to be positive or negative, 0 is also a root. Okay, now let's try one more example. If I have something like this, there are two sign changes because it goes 1, -1, 1. So there's two sign changes. And I can see I get 2 or 0 positive roots. And if I plug in -x, I get x squared plus x plus 1, so we know there's 0 negative roots. And this is what the rule of signs tells us. Now, if we wanted to do a little further investigation, if we know something about the quadratic equation, we know the part inside the square root would have to be positive in order for there to be positive roots. So we could always do that b squared minus 4ac trick, see that, well, if I took b squared minus 4ac, that would be negative. So this polynomial has no positive roots and no negative roots. But that's something a little different than the rule of signs.